Hi, I'm Scott from Luna Innovations. I support our optical communications test product lines, including the Lightwave Analyzer. When you purchase a Luna instrument, such as an optical backscatter reflectometer, an optical vector analyzer, or a Lightwave analyzer, you are investing in a very sensitive test instrument. As such, Luna encourages our customers to take care of their instruments to ensure longevity. One of the key areas of care for your Luna instrument is making sure that the optical connectors on the front panel are maintained and kept clean. Every Luna instrument sold has some starter cleaning supplies included. The exact supplies will vary by instrument, but most instruments will include some lint-free microfiber swabs, as well as a Cleatop-style dry cleaner for the mating connectors. These supplies are considered consumable, and replacement supplies can be purchased through several online fiber optic supply vendors. It is also helpful, but not required, to have an inspection scope available to verify the cleanliness of the connectors. Please note that the instrument should be powered off when scoping the front panel connectors to ensure that no laser light is emitted into the scope. This is especially true for passive analog scopes that are directly viewed with the human eye. Before we get started cleaning, let's use the optical scope to capture a before image. As you can see, the scope has detected some contamination on the end face of the fiber and is giving us a fail indication. This connection needs to be cleaned. The lint-free swabs are used to clean the front panel connector. To do so, insert a dry swab, rotate either clockwise or counterclockwise, but not back and forth, and remove the swab. If the connector is extremely dirty, you may need to use isopropyl alcohol on a swab with a similar motion. If you use alcohol to clean the front panel connector, always follow that up with a dry swab to remove any residue from the connector's end face. Now we can use the optical scope again to check our work and capture an after image. As you can see, the scope does not detect contamination on the end face of the fiber and is giving us a pass indication. This tells us that the connector is clean. The Cleatop is used to clean the cables and connectors that are going to be connected to your Luna instrument. To do so, press the lever, which will reveal a fresh section of lint-free microfiber cloth under a clear fiber guide that has two slots. In one of the slots, press the connector onto the cloth, turn 90 degrees, and then drag to the other end of the slot. Repeat this a second time using the other slot. You may hear a faint squeaking sound when the connector is clean. You can check these with a scope too, if desired. Luna also recommends the use of a sacrificial jumper for our test and measurement products, including the OBR, the OVA, and the Lightwave Analyzer. A sacrificial jumper is a short single fiber cable that is left connected to the Luna instrument, and the far end of the cable gets connected and disconnected from your device under test. In this way, the jumper will take the abuse of repeated connections and disconnections rather than the front panel. Then, when the end face of the jumper becomes damaged from repeated use, you can quickly replace an inexpensive jumper instead of needing to send your Luna instrument back for a much more expensive front panel connection repair. Another advantage of a sacrificial jumper is that it can serve as an adapter to different connections. Luna's optical communications test products use an FC-APC connector. This connector was chosen due to its low insertion loss and return loss, as well as it being a screw-on connector that provides a very secure connection. However, FC-APC connectors are not common in other industries such as data centers, where smaller connectors such as LCs or multi-fiber connectors such as MPOs are preferred due to their higher fiber density. As an example, here's a sacrificial jumper that connects to the Lightwave Analyzer using an FC-APC connector and connects to a device under test using an LC-UPC connection. Now, let's put what we've been talking about into practice. When taking measurements through a sacrificial jumper, you will see both the front panel connector and the connection from the sacrificial jumper to the device under test. It is important then to understand that length measurements within the device under test need to be taken relative to the connection to the sacrificial jumper, not relative to the front panel connector. This can be done through the use of vertical markers. Set one marker at the end of the sacrificial jumper, the other marker at the end of the device under test, and use the delta value to determine the distance between the two markers. Additionally, Using the event table, you can click the Show Event Distances checkbox, then click on the event for the end of the sacrificial jumper, and you will see that all measurements are now shown relative to the position of the end of the sacrificial jumper. I hope that these tips will help you maximize the life of your Luna instrument and reduce the likelihood of needing to send your instrument back to Luna to have its front panel connector repaired. Thank you.